Okay, for the next exercise, the same thing, solving a non-homogeneous differential equation. How do you know that? It's by looking at this equation, second order differential equation. We have fx equals to x, which means it is polynomial to the degree of 1 degree polynomials. Okay, so in general, for solving a non-homogeneous differential equation, we either use undetermined, okay, coefficient methods or variation of parameters methods. So okay, let's get to work. So first of step, we might want to write this equation in the forms of characteristic equation. Okay, so in here, characteristic equation is, we can use the letter r, okay, r square plus 2r, okay, minus 0. So we have x here is our fx, which is, okay, that makes it homogeneous. We will do that later. Okay, we just work out the characteristic equation to be r square plus 2r, okay, equals to 0, to get, in this case, a equals to 1 and then b equals to 2, okay, and the value of c equals to 0. Okay, so if you check the value of b square minus 4ac, this is also greater than 0. Okay, 4 minus 4, so you will have the roots to be r, okay, plus 2 minus 0. In other words, our roots is negative 2, r1, and r2 is 0. Therefore, our complementary function, okay, yc, we can expect it in the forms of a constant y, c1 times e to the power r1x plus c2 times e to the power of r2x. So just plug the value of r1 and r2. Okay, c1, r1 negative 2x plus c2 times e to the power of 2 is 0x, which is basically 1. Therefore, our complementary function yc equals to c1 e to the power of minus 2x plus c2. So this is our complementary function. Okay, next we will look at the second terms, which is the fx. Okay, so our fx or gx in this case, okay, is x, which is that one. Okay, so it is a degree 1 polynomial with degree 1, and therefore we can expect, this is a polynomial degree 1, even though it's only 1. Okay, 1 terms, not really polynomial, but never mind. We can expect the particular integral form to be x to the power of r times ax also to the power of 1 plus b. Just like before, we start with, okay, we start with r equals to 0, so that makes the yp x to the power of 0 ax plus b. I just highlight this for you guys. So it is 1 because this is also 1. So this becomes ax plus b. So compare with next step, compare yp with yc for similar terms. So in this case, ax plus b, and then our yc is c1 e to the minus 2x plus c2. Okay, so in this case b is a constant, and then c2 is also a constant. Therefore we cannot use the r value of 0. Okay, so this is our yp, and then this is our yc. Similar terms, I just write down similar terms b in yp with c2 in yc. Therefore cannot use r equals to 0. So now if we increase r to 1, our yp becomes x to the power of 1 plus x to the power of r. Okay, similarly ax maintain 1 because our polynomial function is to the degree of 1 also, plus b. So this becomes ax square plus bx. So now we again compare. Okay, compare yp with yc. Okay, in this case no similarity because our ax square plus bx is not the same as c1 e to the power of minus 2x plus c2. So there is no similar terms. Okay, they are all unique terms for between yc, okay, and yp. This is our yc, and then this is our yp. They don't have similar terms, therefore we can proceed with r value equals to 1. Therefore our yp equals to ax square plus bx. Okay, so that one. And the next step, just like the explanation, we take the first derivative, okay, of dyp with respect to dx equals to 2a x plus b, because we are going to plug this into the main differential equation, second order differential equation. So we take another derivative dx square, which is equals to 2a. Okay, this is our second equation. Plug 1 and 2 into the second order differential equation, which is d square y over dx square plus 2 dy dx equals to x. Okay, so d square dy square is 2a, okay, plus 2 dy dx is 2a x plus b. The whole thing equals to x. So if you work out this, you will get 4ax plus 2a plus 2b equals to x, and therefore a equals to 1, a equals to 1 over 4. Okay, similarly you have 2b plus 2b equals to 0. So this is equating, yeah, this is equating the coefficient. I just write down here, equating the coefficient, okay, where you have 2a, okay, and 2b equals to 0. So this is 2a plus 2b equals to 0, which is basically this is plus 0. And 4a equals to 1 because there is a 1 in here. So 2a plus 2b equals to 0. You will get a equals to quarter to 1 over 4 plus 2b equals to 0. Therefore you will get b to be negative 1 over 4. And we can plug our a and b value. This is our b value and then this is our a value, okay, into the yp, okay. This is the yp that we have, x squared, okay. I just do on the right hand side here. So yp equals to a, which is a quarter, okay, x squared plus become minus, okay, also a quarter x for b. So y equals to yc plus yp, okay. Y equals to yc, we already know that is equals to c1 times e to the minus negative 2x plus c2 plus yp, which is a quarter x squared minus x. So this is the solution